We are on page 4. All right, so the first 2 sections we learned how to multiply and divide radicals. We are going to add and subtract them now. Okay, similar to multiplying and dividing, you can only add and subtract radicals if they have the same index. Okay, so you can only multiply or divide if they have the same index. But this time, in addition to that, they have to have the same radicand. Same index, same radicand. All right, let's check. Let's try the first one. Number 1. Square root 5 plus 3 square root 5. If you look at the radicals, do they have the same index? Yes. Do they have the same radicand? Yes. Can we add them together? Yes. Okay, so the way we add them is we just add the coefficients. Just think of it as 1x plus 3x. So if you add 1x plus 3x, how many x do you get? 4. So same thing here. If you add 1 radical 5 plus 3 radical 5s, how many radical 5s do you have? 4. So the answer is 4 radical 5. Okay, just think of radical 5 as a variable, and you're just adding the coefficients. Easy stuff. Number 2. Can I subtract them?
Yes.
Yes. Why can I subtract them? Same index? Same radicand. Good. All right, so 7 cube root 4 minus 2 cube root 4 equals what? 5 cube root 4. Yeah, cubic root of 4. All right. Next, number 3. Can I subtract them? Yes. Easy stuff. Okay. Number 4. No. No. We can't do it. Square root 7, square root 5, they're not the same. We cannot add them or subtract them together. Number 5. All right, talk to your partner. Can I add or subtract this one? Yes. Can I add or subtract this one?
You can add and subtract.
So, how many people think yes, you can add them? Okay, how many people think no? Okay, you can. But they don't look like they have the same radicand. So why can't we subtract them or add them? Yeah, we had to simplify. Okay, so this becomes 2 root 3. 75, just think perfect square. What's a perfect square times another number for 75? 25 and 3. So this is 5 root 3 and then square root 3. So now we get 6 root 3. So the bottom line is you really need to simplify first before you do anything in radicals. All right, number 6, try this on your own. Let me know when you're done. All right, the answer is 6 cube root 2. Now we're going to multiply binomial expressions together. We are going to use FOIL. So for example, this first one. Well, we're never going to escape FOIL. Okay, so we are going to take the first term times the first term. So 4 times 5 is 20. Easy. 4 times 4 root 2. 4 times 4 root 2 is what? 16 square root 2. Okay, do not multiply the 4 into the square root, okay? Just coefficient times coefficient. 16 root 2. 2 root 2 times 5 is 10 square root 2. The last one is kind of the hardest one. 2 root 2 times 4 root 2. Okay, 8 root 4 or 16. Just think square root 2 times square root 2, the 2 is going to come out. And then so it's 2 times 2 times 4. Okay, so that's 16. Now we combine like terms. Okay, 20 and 16, they're the same. They're the same kind, and they are both whole numbers. 36. 16 root 2, 10 root 2, they are both root 2, so you add the coefficients together, so it's 26 root 2. Good? Okay, so just do your foiling like normal. If you do need to do side notes for the radicals, do that. Okay, let's have you practice. Number 2, let me know when you're done. There is 8 minus 2 root 7. All right, last part. We just cannot have radicals in the denominator. Okay, so when you see radicals in the denominator like this, what we did today was in a warm-up or the past 2 days is you rationalize it by multiplying by whatever it is to get out of the radical. But when you have something like this where it's a binomial, you cannot just multiply it by a square root 5 and then a square root 2 to get it out. You have to multiply by something called the conjugate. So we've been doing conjugate for like 2 chapters already, right? What is the conjugate of the denominator? Plus square root 2. Yeah. So we need to multiply by the conjugate. And remember, when you multiply by conjugate, it has to be top and bottom. All right, so let's just remind ourselves. We need to rationalize the denominator by multiplying by conjugate. Okay, so same thing that we did last chapter. When we have i's, we gotta multiply by conjugate. All right, let's solve this problem. Okay, let's solve this problem. So we are going to FOIL. 3 root 2 times root 5. 3 root 2 times root 5. The rule in multiplying is we just have to have the same index. Do they have the same index? Yes? When they have the same index, what do we multiply? The radicand. Okay, so this becomes 3 root 10. 3 root 2 times root 2 is 6. Just 6. Denominator. Well, this is a minus b times a plus b. A minus b times a plus b, by this time you should know. What is it? Yeah? Yeah, a squared minus b squared. So that is square root 5 squared minus square root 2 squared. A squared minus b squared. So this becomes 3 root 10 plus 6 over 5 minus 2. Okay, square of square root is just that number. Okay, 3 root 10 plus 6 over 3. What can I do now to make this a little simpler? Divide by 3. So 3 cancels out for everything, right? So this is root 10 plus 2. Yes? No? Yes? Which part? If you're stuck. 6. Oh, okay. All right. So when you multiply, 3 root 2 times root 2 is 3 root 2 times root 2. The roots, when they multiply by each other, it just comes out. So just 2. Yeah. Oh, I'll help you later. Okay, let's let you try one. Let's have you try number 1. Let me know when you're done. Number 1, the answer is minus square root 21 minus square root 35. Good? Yes. Okay, number 2, if you tried it, is 12x plus 4 root 6x over 3. We usually don't write 4x root 6. We always put all the numbers together and then the variables behind it. All right, so here is what we're going to do. I'm going to have you practice 1, 2, 3, 4, 5. Okay, let me know when you're done with all 5.